PowerUp Consortium, co-funded by the EU in the 7th Framework Programme, presents its results. PowerUp is a collaborative project for the specification, implementation, field trial and standardisation of the vehicle-to-grid interface. The introduction of fully electric vehicles puts a significant strain on electricity production plants and distribution grids. This change on the consumption side occurs at the same time as supply capacity becomes more variable, due to renewable sources being increasingly widely adopted. It is therefore essential for the security of our power network that the supply and consumption sides become better coordinated, especially to meet the demand of these new heavy loads. The vehicle-to-grid communication interface is an essential mechanism for this coordination. It is being standardised by the ISO IEC 15118 and the IEC 61851 groups, and is expected to become part of every electric vehicle, or EV, in the near future. Possibilities to negotiate charging schedules and power levels will accelerate the deployment of EVs by avoiding disturbances in the electric grid. The charging of the EV fleet will be adjusted in tandem with the local power availability in the grid. Here's an example of how this coordination might work in practice. Bill is a driver for a company that delivers goods in the city centre. The company uses electric light trucks, which means they get access benefits in the town centre. Today he has completed his deliveries and is just heading back to the depot. Bill can see on the display that his vehicle has to be recharged at 6 AM since he has to run out for the delivery on the next day. To make this possible, a vehicle-to-grid charging session was started as soon as the vehicle was parked and connected to the charging spot. The vehicle-to-grid session is delivered by a large number of components working together. Some of these components are in the vehicle, some are at the charging spot, and some are further away coordinating activity with the power grid itself. The charging spot components are the energy meter, which measures the amount of power delivered to the vehicle, the vehicle-to-grid control unit, which handles the session with vehicle and also to the systems in the grid, the home plug green PHY communication module, which provides the communication link to the vehicle. On the vehicle, the components are a home plug green PHY communication module, which provides communication with the charging spot, a vehicle-to-grid control unit, the gateway unit, the user interface connected through wireless communication with the onboard system. In addition to the real vehicle, for the purpose of this demonstration, another virtual vehicle, referred to as breadboard vehicle, is connected to the grid through UPA powerline modems, linked to a vehicle-to-grid control unit. The load balancing controller is the part of the system that coordinates with the power grid. It connects to the energy meter through GPRS, being inside of a virtual private network. Once connection is established, communication can start. The session is set up following the ISO IEC 15118. Several steps have to be taken, like the proper linking to the correct smart meter, the discovery of the IP addresses, as well as protocol compatibility checks. After the communication-related initialization, the electric and electronic characteristics are checked and set up. Having finished all compatibility and safety checks, a request is sent by the EV to retrieve a certain amount of energy by a desired departure time. Through the smart meter, the load balancing controller receives the request, executes the load balancing algorithm and returns a new charging schedule defined according to grid constraints. The actual charging and communication loop starts right after the power delivery messages, indicating that all systems are ready for charging. So, with his vehicle plugged in, Bill sets the deliveries for the next day. Then he receives a call from his boss. An emergency delivery is needed in 45 minutes' time. The destination for the emergency delivery is not so far, but a full power charge for Bill's vehicle is needed. Other vehicles can't be charging at the same time. The breadboard vehicle pauses charging and a renegotiation for Bill's vehicle is performed. The new charge profile is set and the new earliest departure time is 3 p.m. Bill waits with a coffee for the package to arrive. At the stroke of 3, the helicopter lands to deliver Bill the parcel. Bill disconnects the vehicle from the charging spot. It is safe to disconnect and vehicle-to-grid session is closed. Bill drives off very fast, almost forgetting the emergency parcel. After the prioritised vehicle finished, the other vehicle can resume the charging. Bill's boss verifies the total delivered energy and that all the other vehicles will be charged on time. He can finally relax. The emergency delivery has been made, thanks to the proper coordination through vehicle-to-grid communication.
Table we can see all Corinex PowerUp setup, which consists from 3 devices. 2 smaller boxes are IV2G and AV2G adapters. IV2G adapters is connected basically in the charging spot, and A adapter is connected in the car, and the third unit, the larger unit, is head end, which controls the whole network. We are simulating this setup via coaxial cables.